G'day and welcome back to RC Model Reviews, and today I'm looking at this diversity receiver from Quanum, which is a Hobby King brand, and there it is, unboxed. Actually there's two there. What's going on? Well, this is the diversity receiver. This is the auto scan receiver. Now effectively what you're getting for your money here is two of these in there, but you're getting a whole lot more because it's more than just two video receivers. This is actually quite a full-featured little bit of kit. I'm actually pretty impressed with the functionality it offers, and let's just get rid of that for a moment and concentrate on this. What we have here is a plastic case, smoky case. It's got two antenna connections because there are indeed of course two receivers in there. It has an OLED display which is the same as on the auto scan, same display, but it does more stuff. It's got the two AV outputs just like the auto scan has. See, auto scan has two AV outputs. It has a 2.5mm barrel connector, which I'll talk at length about shortly because I hate those damn things. And it has a little joystick here which goes up, down, left, right, and you can also push it as a button. That's your control interface. The old auto scan or the auto scan just has a couple of buttons like that. This is a more complicated, more complete user interface, and it works pretty damn well. But before we actually get into seeing how it works, why don't we pull it apart, see what's inside? And once you take the board out of the case, this is what you get. Well, that's half of it. The other half's on the other side. But let's just have a quick look at this first. What we've got here is a 40-channel, 5.8 gigahertz video receiver. Now, the specs on this receiver look pretty damn good, very sensitive, but I will be testing that at a later stage. On the other side, that's where all the goodness is. But before we go there, let's just have a look. One thing I don't like, and I always said this, I don't like this black resist, this solder mask on the back. But having said that, you have to have that because this is the racing edition of this product, and black is faster, so it has to be black. I'm sorry, that's just the way it is. Anyway, let's turn it over. Let's take a bit of a closer look at this thing. I'll just walk you through the bits and pieces that are on this board. Down here we have that 2.5mm barrel jack I was talking about, the hideous, horrible, worst thing in the world for power connections, and I'll show you why shortly. There's a little diode. That means we've got reverse polarity protection. If you plug your battery in the wrong way round, wire it up incorrectly, the magic smoke is unlikely to come out because this diode will stop the power from flowing through the circuit. That's, I mean, these are only like 5 cents, so why not include them? And some don't. Some receivers, if you plug them in backwards, smoke will come out, but this is a good one because it doesn't. The power then goes through to this little chip here, which is our voltage regulator. It's a switch mode voltage regulator, but like a switching UBEC that brings the voltage down because this will run from 2 to 4 cell packs, but all the other goodness in here runs on about 3.5 volts. So if you didn't have this regulator, then you'd have up to 16 volts rushing through here, making a hell of a fire and mess everywhere. So that's why this is so important. This little chip works with this diode and that inductor to step the voltage down to a more usable level that the other chips use. And here's a big smoothing capacitor on the output to make sure there's no noise on there. It's so simple. We've got a buzzer here which beeps. We can set it to beep when it changes receivers during the diversity. It'll probably also beep if your battery gets low to let you know, because when you're wearing goggles, you can't tell the stuff. You don't know if the diversity has changed receivers with your goggles on, so a beep is a really handy thing to have. Now, if we go over here, we've got ourselves a microcontroller. That's the computer, the brains of the thing. It's actually an ARM processor, an ARM Cortex-0 processor, which means it's got plenty of power. It's really quite handy. So this is neat. This has got an ARM processor. How cool is that? Now, we've got another one of those receiver, 5.8 gig receiver modules there. So there's one, and on the other side, there's the other. Those are our two receiver modules, and they're independent. They operate separately. And then what happens is the signal comes in, and down here we've got a couple of video switches. These little chips can choose from, they can choose either receiver, and we've got two of them. You might think, well, why two? Because, as I'll show you later, this diversity controller can either run these two jacks in parallel, which means that whichever has got the strongest signal, whichever receiver produces the strongest signal, will be sent to both of these AV output jacks. So you can have your goggles on one and a DVR on the other or something. However, one of the nice features of this little thing is that you can also set it up so that it runs as two separate receivers. So one receiver will be switched through to this jack, the other receiver switched through to that jack. And that's great because then you can use it for 3D, because each video signal will be on a different channel, one for each eye, or you can just have it set up so that two people can use the one receiver or the one diversity receiver at the field. So you don't have to set up two receivers if you've got two people flying. That's kind of cool. Now here's our little joystick, which moves up, down, left, right, and pushes in and out. There's some additional bits and pieces over here. I think probably got a 3-terminal regulator or something. I'm not quite sure what that is. And I don't see where the audio is switched, but it's probably that device and that device. I don't know. I'm just guessing. Here is our OLED display, these are really good in bright sunlight, much better than a backlit LCD because they work in bright sunlight or low ambient lighting. Quite a cool little thing. A little bit small if you've got old eyes like me, but hey, you know, young people use these things too, so we can't grizzle. Up the top here we've got two LEDs. There's a red one and a blue one. Red one and a blue one. Show you what they do later on, but they give you a visual cue as to what's happening inside this diversity control. Now looking at it, the quality of construction seems pretty damn good. The reflowing of the solder is very good. Component choices seem fine. I've got no real complaints except for this bloody thing here. What a piece of crap the 2.5mm jack is. And well, let's take a look at why that is. But first, let's take a look at what else you get in the box. You get the instructions, and hey, color printing, woohoo! And these instructions, they stay on the bench. These aren't actually too bad at all. One thing that it says up here, it is 32 plus 8 channels. Yet it says on the box or something it's 32 channels, I think. Oh no, 32 plus 8, yeah. A little confusion over how many channels it's got. But these are the channel allocations somewhere. No, it doesn't show them. Oh, it doesn't show which channels. But someone mentioned to me that the bands are not the same as normal that you find on your Sky Zones or whatever. So it could be a bit confusing as to what channel to select because there's the bands don't necessarily correspond to the bands used by other vendors. I don't know, haven't looked at that. But one thing with the auto scan, it will show you the frequency that you're on as well as the band and channel, which makes it a little bit easier to find out where you are. So you get the instructions, you get the receiver, you get a power lead with one of these evil 2.5mm barrel connectors. You get a 3.5mm to RCA plug lead. We've all got hundreds of these. And you get a couple of antennas. No, I'm lost for words. I was going to say no price is spared, but look at more of these. I have a mountain of these. What can we do with them? That's a good idea. If anyone's got any ideas as to what we can do with the hundreds and hundreds of crappy 5.8 gigahertz linear video antennas that we all end up with over time, send that to me. And if I like it enough, I'll send you a t-shirt. Because, oh man, I've got so many of these damn things. And these ones, I'll open it up. Because one thing that really annoys the snot out of me is when they don't write on them what frequency they are. Or these ones do. These have got 5.8 gigahertz on the base, but some of them have no writing, so you don't know, is it 5.8, is it 2.4? I'll pull my hair out. Anyway, so that's what you get. I also got this in the box. Look, that lead, I have no idea what that lead is for, but it was in the box. There's nowhere to plug it in. There's no mention of it in the manual. Maybe the person putting it in the box had it hanging around their neck and it fell in. I don't know, but it would be nice to find out what that's for. No bleeding idea. Anyway, there we go. So now I'm going to wire this up. I'm going to connect it up. I'm going to show you it working, and I'm going to show you it not working. All because of this. Okay, so we got it all plugged in, ready to go, and I'll walk you through the display here. It is a bit configurable. We can change some stuff. Here's our battery voltage indicator up here. This can be also set to volts, so it doesn't have to be the little 3 bars or the 3 marks on there. You can have actually the voltage displayed there. This number here is which receiver is active. That's number 1, that's number 2. You can tell number 2 is active because the red LED is on. And you can also tell that there's no video transmitter being received because the blue LEDs are out. So this is just sort of sitting there, no signal, minding its own business. Now down here it says we're on race band channel 7, which is 5880 or 5.880 megahertz. There you go. It's pretty simple. It shows you here, this little flashing thing shows you where on the band that channel sits. It's right at the top there. It's quite high, right up at 5.88. Now obviously we've got a little joystick down here, and I'm going to push the joystick and it should pop up a menu. Hang on, I'll switch to a closer shot so you can see what I'm doing. Now this way hopefully you can see the screen in more detail. I'm going to press the button, get up the main menu. There you go. Now we don't have this on the auto scan. There's a whole lot of really cool functionality built in here. The first one is channel scan. I'm going to select that and you'll see it goes across the entire band. It's a bit like a spectrum analyzer, but it only goes across once. And that's basically what our band looks like. It's pretty quiet. I've got no video transmitters on, so nothing to see here. Let's move along. Press the menu button again. Let's go down to spectrum analyzer, and you'll notice it's going to do the same thing. It's actually scanning the band, and you can see the scan as it moves across here. This little level's dropping. Remember, this is our active channel that we're on at the moment. Just waiting for that to go across. And it'll do it again. Once it gets to the end, it'll go back and rescan. So it's like a constant dynamic checking of the band. It's pretty slow. It's not really a spectrum analyzer. It's pretty minimal in terms of its functionality. But, you know, there you go. What I'm going to do in a moment is turn on a transmitter and we'll see what happens. Okay, I've turned on a transmitter and you can see immediately that suddenly we've got 2 bars appearing, well, several bars appearing here. And this is because the transmitters that we're using, they're not that good. They tend to have some spurious radiations. And also these receivers, they tend to have a bit of a broad front end. Sometimes they pick up harmonics. That's why we have 40 channels, but we can't run 40 models at the same time on FPV because the bands overlap and there's interference between them. So this shows you what we're getting on with there. Now what I'm going to do is go out of here. I'm going to do my channel scan again, and it should find my, there we go, ooh, look at that, there's my active frequency, and it should turn me to that frequency, I think, when I go back to here. There we go. Yes, it has, because we can tell, because we've got a blue light here, which means this is getting an active valid signal, and this previously red light's gone purple because it's red and blue. And if we look at this display, we can see some cool stuff. There's our signal strength, the little bars, and the little V there means this is a valid video signal. It's not just noise or some other interference. It's actually a video signal that we can use, and that's really, really handy. So I'll just go back to there. Oops, sorry, I didn't mean to do that. I meant to go back to something else. Let's go back to the menu, go down, let's turn on the diversity. Bing, bing. There we go. Now this is showing us that we are locked into this channel down here, which is 5.880, I think. And why was that up there before? I've no idea. I'm still getting to grips with this thing. Now, one of the interesting things is that depending on how you get reflections and things, and maybe I can get it to do it, I'm not sure, you can get some of the V's to disappear by, it's probably not going to happen because, no, I can't do it. But we can see that we're on receiver 2, which is why this has got the red light as well as the blue light, receiver 2. Because I've got the antenna, I'll just back out a bit here so you can see what's going on. Whoops, goes a bit fuzzy, but she'll be right. I've got the antenna plugged into receiver 2. Now if I take that off there and put it onto channel 1, one would hope, but it's not a guarantee, that it will change to the other receiver. Let's have a look and see. Is it going to do so? No, it's not going to, and that's because of hysteresis. With both channels have got reasonably good signal down here. You can see where they've got plenty of bars and they've got a V, which means there's no point in changing channels because it would be an unnecessary switch. They're both providing signals that are strong enough for the receiver to pass on a good signal. Let's turn on our LCD and see what sort of picture we're getting here. I don't know, I've got this out in the workshop and it's really dark out there, so we might not see too much. Here we go. This is the DVR LCD. It says no signal. Why is there no signal? I don't know. Have I got the thing plugged in wrong? First of all, this video has actually taken me a long time to do. I've had several attempts at it and really haven't succeeded very well. So I'm just looking to see why I don't have any video. Oh, there we go. My connection was not quite complete. There we go. There's the front of my workshop. You can see. I'll just move this over so I'll take a bit of a look there. See, that's a pretty good picture, even though we're actually receiving on the receiver that has no antenna connected to it. What I might do then is connect up a terminator. Now, terminator is just seals off the end of that receiver, so hopefully that will reduce the strength of signal coming in on here and encourage it to switch. Will it do so? No. Well, it's dropped it a little bit, but not enough. I might be able to move my hand around here and get it to drop out. I'm not sure. Can I see if I can get a null going on here somewhere? You can see the little bars going up and down, but my hand isn't that reflective. Oh, there we go, the V is gone, and see the signal is quite crappy. Try and get that happening again. There we go. Now I'm a bit surprised that it doesn't switch. Notice here we've got the V is going in and out. We've got very few bars of signal on here, but it's still on that right-hand receiver, even though we've got this crappy ass picture. It's not changing. Why is that? Why is that? Why is it not changing? How can I force it to change? See if I can get this going here. Try and get that really bad picture. This is just creating some multi-pathing with my hand. So I mean, we're getting that. That should really cause a switch to the other. There we go. We've even lost the V. It still hasn't switched. Come on. What's going on here? No. No. So I got to worry a bit about this, about the switching of the diversity here. It's not what I would expect to be very good. Should have switched then because I'm sure this other receiver has a pretty good signal. In fact, what we can do is we can probably force let's go into here. Let's go down to independent. Okay. So now I'm plugged into that receiver. It's a perfectly good signal, look. But if I go back to diversity and I null out the other channel with my hand, which is really a sensitive movement here somewhere. Where are we? Come on. It just doesn't seem to be switching as I would expect it to switch. Let's get rid of that almost completely. See, you don't have to move very much to get that massive drop in signal. Come on. There we go. Look at that. That's quite an awful image. But it hasn't switched. There we go. It switched then. Right. See, so now it's switched to that. And now this makes... But why did it take so long? I'm kind of a little disappointed in this. The diversity should be much better than that. That is... And you'll notice it's gone to 1 because it's using receiver 1. That is amazing. See how bad that signal got when we had a perfectly strong, valid signal on this receiver and it didn't switch. What's going on here? Now, I know this diversity receiver has special algorithms because it tells you if it's got valid video. It's got a V under there if it's valid and a V under there if it's valid. But even when the V disappeared, which meant the diversity controller thought that's not a valid video signal, it still wouldn't change to the valid signal. What's going on? It seems like great functionality, but is it really working? Is it really working properly? I won't know until I go out there and test it in the field, but I've got to say that's quite concerning. You saw as well as I did that this thing, it would not switch to the cleaner signal. And even when the signal was really, really bad on the receiver it was using. That's pretty poor. So I reserve judgment on that part of the functionality until I've had a chance to test it in the field. But right now, based on the bench, maybe this one's faulty. I don't know. Okay, I'd like to talk a bit more about this barrel connector here, these 2.5mm barrel connectors. This all seems to be working just fine at the moment, but yesterday, when I was trying to make this video for the first, second and third times, this was intermittent, and I thought maybe there was a fault in the receiver, but I've tried another 2.5mm barrel connector, and it seems fine. So it looks like it's just the tolerances perhaps between the different connectors, the barrel connectors and the sockets is just very poor. Because now this is solid as a rock, but yesterday when I was tapping it, here's a bit of footage from that, the damn thing was going off and on, and wiggling the wires would also make it go off and on occasionally. I tried 2 different leads, one was better than the other, and finally I found one today, which isn't the one that came with it, found one today that actually works really well. So is it the reviewer's curse? Did I just get a bad one? Or has this actually, a fault with, a common fault with the 2.5mm barrel connectors? They're just not made to an exacting enough specification, so you tend to get intermittency. I have had the same problem with this LCD, the barrel connector, and there sometimes goes wonky and I can't keeps turning itself off and on because the barrel connector is loose. I think the 2.5mm ones are just too small to do a good job. Any kind of physical load on them, and they tend to disconnect. So I'd rather see a proper, 3.2mm connector or whatever they are. The standard barrels, they've got a bit more latitude because these ones don't have the little split pin in the middle. I don't think it's just a wire, and therefore it can quite easily not contact the barrel on the plug. So yeah, something to consider. Going back to these menus, as you can see, we have, and diversity was where it basically chooses the strongest signal, feeds it through to both of the AV output ports independent. As I say, that is when you can have each receiver operating totally independently. So the right-hand receiver goes to the right-hand AV output, the left-hand receiver goes to the left-hand AV output, and you can set up the frequencies of each receiver independently. And as I say, that's good for 3D, and also if you want to have 2 people using the one receiver. You will need 2 antennas, of course. Now, there are some other... I'll just get my glasses because I'm old and I can't read that tiny little display. As I say, it is a bit of an issue for old people like me. If you're young, you won't have the problem. Right, and there's some options you can, when you're doing things, you can skip the low S. Well, I'm not going to go through all these because obviously if you're buying one of these, you'll work out how to use it. But there you go, you can set your battery alarm levels, so you can run it from 2 to 4 cells and set your alarms accordingly so you don't get caught out. The RSSI mode, you can have the little bar graph there, or you can have digits. So it'll show you in percentages what the RSSI, see that changed to percentage, so you can see what percentage of RSSI you've got. The battery mode, again, it can display a voltage or the bar graph, like so. I think I'll set it to voltage, I like that. And then you've got RSSI beep. That just means when it changes from one antenna to the other, it'll give you a beep. So if you're wearing your goggles, you know the diversity side of things is working. And that's quite important because if you get in a snowy picture and there's no beep, you're thinking, what's going on? Has an aerial fallen off? Has a wire come off? I don't know. So there you go. And then we go back to, to the previous screen. And that's really about it. So yeah, it's quite a full function little receiver. So it's got a sort of a very rudimentary spectrum analyzer. It's got auto scan, and It does all the channels you probably want. Maybe not in the order you want them in, but there you go. Right, it's time to teach everyone how this video signal system works, where you notice on that receiver it has a little V when it detects a valid video signal. How does it know what's a valid video signal and what is just noise being picked up or interference, and what if the signal is distorted and can't be received properly? Well, what I've done here is taken the output from our receiver and I've put it into the oscilloscope, and I'll just try and get around the camera here so I don't knock things too much. It's not an easy task. I'm going to set the trigger here so hopefully we'll get a stable waveform. There we go. Oh no. What I'll do actually is I'll just stop this. There we go. That is the waveform that's coming out of our video receiver, and each one of these represents, the old television systems had a thing called scan lines where the TV phosphor was scanned by an electron beam, and it's the same with the modern stuff except we have lines of pixels, and this is one line of pixels from here to here. That's the information that makes up a line of pixels, and every line starts with what they call a horizontal sync pulse. What's that mean? Well, it just tells the circuitry to reset and start writing to the pixels again at the beginning of a new line. And you can see these pulses here are the sync pulses. And if we look at, I'll tell you what we'll do, let's just go back, let's turn that back on. Oh, wrong button, there we go. And if I turn off my video transmitter or change the channel, let's change the channel, that's what noise looks like. See, it's just complete garbage. If I go back and turn the signal back on again, somewhere, oops, wrong button. Here we go. There's our video signal back. Right, so you can see the video signal looks a lot different to noise. I'll just stop that again. No, find a better, it's getting, because I'm using an RF link, we're getting all sorts of distortion, and my hand's in the way, I'm sorry. Right, so there we go, we can see our, still a bit distorted, but we can see we've got our sync pulses there, so we can measure the gap between there by using some cursors, which I'll just, God, I must work out a better way to film my oscilloscope. Oops, bang the microphone as well, hang on. So I'll turn on my cursors. Here we go, and I'll move them along. So let's move along cursor B to this one here, and I've got them both there. Let's move cursor A along to this. So we measure the gap between the individual things. So it'll confirm that this is a scan at 15.8 kilohertz, 63 microseconds. That is indeed the amount of time it takes to send one line from your video camera. So that is one line of signal from there to there. And so if our diversity receiver checks to see that we've got these pulses and that they are the right spacing, it can pretty much be sure that it's looking at a valid video signal. And that's how it knows when to put the little V up on the screen of that diversity controller. I mean, that's one way. That's the way I'd do it if I was designing it. And that's the way I know some intelligent diversity receivers work. So we can pull out of that noise or pull out of the signal information that will tell us whether it's actually a really good viable video signal or whether it's just, let's go back to make it run again. I turn off the transmitter. That's the noise. Obviously, now, there's just random stuff there. So we can tell that's not a video signal. So there it is, the Hobby King 5.8 gigahertz, 32 plus 8 channel video receiver. And certainly it looks like it works really well, except I'm still concerned about the way it handles diversity. It's got spectrum analyzer, band scan, it'll operate in a 3D mode, or it'll operate so two people can use the one little box to receive their signals. It's got all these wonderful features, but it looked like the diversity was actually not working pretty good. So maybe it's got lots of features and the functionality is flawed. I don't know. What I'm going to do next is fly with it. Hopefully I'll do it this weekend so I can give you a follow-up early next week as to how it performs in the field. But right now, I'm scratching my head a little bit. Maybe this is a faulty one, or maybe it's just that they've got the algorithms wrong. I don't know, but we'll take it out and we'll try it. So there you go. If you've got questions, comments, anything to say, put them in the usual place on this video. I'll do my best to answer them. And in the meantime, time to clear the bench, get on with reviewing something else. Bye for now.